Yes, hello everyone. So today we're discussing another question. This is based on EMI, electromagnetic induction concept. Let us see the question first. It says that a metal rod of length L attached to a vertical shaft by a non-conducting thread of length small l is rotating on a horizontal plane, okay, with a constant angular velocity omega. Find the potential difference between the ends of the rod. Okay, continuing. Now a uniform magnetic field is vertically upward direction is switched on. What should be the magnitude of the flux density of this magnetic field so that the potential difference between the ends of the rods become double? Neglect gravity and denote the mass and the charge on an electron to be as small m and e respectively. So, as per the question, we are having basically a rod which is rotating in a horizontal plane. So, about an axis like this, the rod is rotating horizontally. So, this diagram is shown for that. The length of our rod is L, and the distance between the axis and the rod is basically small l. The rotational speed they have given it as omega. Okay, so to make our calculation part and all understanding part easier, let us be an observer from the top. Let us look at this from the top. So if we are looking at this from the top, okay, so what we find is we will be seeing, let's say, like this, I can draw here. The same rod I will see like this. Okay, and the axis part I'll be seeing it at just a dot, and based on this rotation direction I would be seeing it rotating like this. So this is the view from the top. As an observer, I'll be seeing this. Okay, now to find the EMF induced just because of rotation, first we have to understand why would the EMF be coming. First part of the question is asking that before even the magnetic field was switched on, what is the EMF induced? So question is, without any magnetic field, why would there be an EMF induced? The reason is very simple. See, because of this rotation, there will be one centrifugal force, right? We can assume a centrifugal force, a pseudo force, acting on all the electrons which are lying on that rod. Because of that centrifugal force, all the electrons would be experiencing a force in that direction, the centrifugal force, and because of that, electrons will accumulate here, creating this side as a negative side. Automatically this side then would become a positive side. This would be happening only purely because of centrifugal force. And how do we write the centrifugal force formula? Centrifugal force can be given as m omega square r. This is the general formula for centrifugal. And this r, for any kind of a regular body like a slender rod, you can always take this r as the location or distance of the center of mass of that rod from the axis. So what's the distance of that center of mass location? This much distance is L, and from here to center of mass it will be L by 2, capital L by 2. So basically my centrifugal force would become M into omega square into I can say L plus L by 2. This is a centrifugal force. And what about the mass? They have said that small m is the mass of one electron. Like that, capital N number of electrons are uniformly distributed in this rod. So I can say total mass is n times m. This much of centrifugal force is acting on all the particles, all the electrons, because electrons are the ones who are free. Other ones I'm not calculating, only for electrons. Okay, so this is the force that is acting on all the electrons. Now, because of this force, as the electrons are shifting into that direction, don't you think now an electric field has been created inside this because of this dipole kind of thing, right? Negative charge here, positive charge here, electric field would be generated. Which direction the electric field would be? This way. Now, because of this electric field that has been generated, the electrons would now be experiencing a force in the opposite direction. You have studied this in electrostatics. Electrons always experience a force opposite to direction of electric field. So now it is experiencing an electrostatic force Fe, which is equals to, we can say, Q into E. This is the formula for that. How much Q are we talking? All of them are electrons. So we are talking about N times E into capital E. This much of electric force, electrostatic force it is experiencing, this much of what you can say, centrifugal force it is experiencing. Finally the rod will come into an equilibrium where this force and this force becomes equal. That's where the induction would stop. But that's why I can say the Fc when becomes equal to Fe, and when that happens, Fc, I'm writing the value Nm omega square L plus L by 2 should be equal to Ne capital E, right? So what can be cancelled here is just N will go. So electric field comes out to be M omega square by E times of L plus L by 2. So this is my electric field. And last step, once you got the electric field, to find potential, it is very simple. The potential is nothing but E into L, right? This L in our case is what length? This length. About this length I'm having the electric field, and that length is nothing but capital L. So I can write it as E into capital L. So my final answer comes out to be M omega square L by E times L plus L by 2. Okay. So this is the EMF induced, we can say, or the voltage produced, EMF induced in this rod just because of pure rotation. Now what we are doing is we are going to start a magnetic field in this region. Now because of my magnetic field, additional EMF would be introduced. Now that EMF may be supporting this EMF, or it could be even opposing, depending on the direction of magnetic field. Two cases are possible, right? But in question they are specifying that magnetic field is in which direction. They specified in the question, I think it was upward direction, right? Let me see. Magnetic field, they have mentioned it as, yeah, now a uniform magnetic field in vertically upward direction is switched on. Okay. So they are now switching on a magnetic field in this direction, vertically upwards. So because of this magnetic field, if I draw that same magnetic field in this figure, it would look like a dot coming out. Like as an observer from the top, if I look at it, look like the magnetic field lines are coming out. So if that is the case, can you think of what will be the direction of the EMF induced? Like, will it be similar to this or will it be opposing it? We'll have to check that. So, if I use my Fleming left hand rule, I use that to find out the direction of the plus and minus induction. So, if I consider the velocity of this rod, say it is rotating like this, omega is in this way, this is how the omega is. So therefore this is how the velocity, if I take a small section here, that small section would be having a velocity like this in this way. So if I use my Fleming's left hand rule, magnetic field is outward of the board and velocity is in this way, and because of that I'm finding that the force is experiencing in this direction. That means the positive charge, Fleming's left hand rule is applicable for positive charge, so positive charge will be experiencing force in this direction, and therefore the negative charges would be now accumulating in this direction. So my point is, because of this magnetic field in the vertically upward direction, I am getting a EMF induced in a very in an opposite direction to my EMF induced due to purely centrifugal. So that means, as per question, if my EMF produced finally has to become double of this value, then if you think logically, right, magnetic field, sorry, EMF induced by magnetic field is opposite to EMF induced by centrifugal force. So if my final EMF has to be double of this value, it will only happen if my EMF produced by magnetic field is 2 times the EMF produced by the centrifugal force. And what is EMF produced by centrifugal force? This is the EMF produced by centrifugal force. My EMF by magnetic field should be double of that. If that happens, then they'll cancel and I'll be getting finally that answer, right? Am I correct? EMF, it is a double. No, not even double. Because if my EB is a double, then what will happen is EB minus EC, if I do, that will be becoming only one time EC. I have to make it 2 times EC. That means this has to be 3 times. Then only when I will be doing EB minus EC will come out to be EB as a 3 EC. If I put, I'll be getting finally it as 2 EC, because the question they are asking you to make it double. So for making it double, the EB has to become 3 times. Okay, fine. That's it. Now you can equate it. This EC value you already know, 3 times of M omega square L by E, L plus L by 2. Okay, And eb value you can easily find out by integrating, right? Each section is acting as a motional emf. That equation we can say this is at a distance of x, and the thickness of the small element is dx. How much emf induced in the small region means we can say de is equals to m, the small dm, into omega into what is the distance of that x square. Okay, now what about this dm? Sorry, we have to use this is, I'm writing the formula for actually uh, centrifugal force, but what we are discussing is motional emf, right? So I made the wrong formula used. What is the formula for motional emf? It is blv, right? So b into l, what's the length of my section? Dx into v. Now instead of this v I can write as omega into r, so it is omega into x. Yes, this is the emf induced for a small section. I want for the entire section, so just integrate. So it will be integration of b is a constant, omega is a constant, it can come out. So b omega integration of x dx. The limit of my integration goes from L to L plus L. So L to L plus L. That's it. You can substitute the value and you'll finally get B omega. It will become L plus L whole square minus L square divided by 2. This becomes your EMF because of magnetic field. So that you can substitute here, and finally using that we will be getting it as b omega. What about the numerator subtraction? If I subtract it, I'll be getting it as L square plus 2ll divided by 2, right? That's magnetic field because of EMF because of magnetic field. That's equals to 3 times of m omega square L by E, L plus L by 2. All right. Now here, whatever can be cancelled, you can do it. That's it. So you are interested in finding the magnetic field required. So one omega can be cancelled here. That's it. Then you can write the B. Sorry, magnetic field is required in the question, right? So B is equal to what will I get? 3m omega L. If I take LCM, it will become 2L plus L. The 2 will get cancelled from both sides, and the denominator would become E times of L square plus 2LL. I can take out the L also from there common, right? I can take the L from here common. L can be cancelled. Inside the bracket, I'll be getting 2L plus L, which can be also cancelled. And I'll be getting B is equals to 3m omega divided by E. This is what I'm getting. Okay, let me check the answer that they have given here. So yeah. Now, the answer that they have given in the back is not matching with this. Okay. So, the answer that they have given is actually only m omega E. There is no 3 coming here. Now, that will be happening only if this magnetic field was actually in the opposite direction. If magnetic field was like this, then magnetic field will not be in this way dot, it would have been cross. If it would have been cross, then instead of plus here it would have been minus, and instead of minus, the blue colored minus that I've drawn, instead of that it will be plus. That means the EMF induced by magnetic field would be supporting the EMF produced by the centrifugal force. That means for the EMF to become double that compared to the earlier, I just have to have the condition EB should be equal to EC. That's it, because both of them are supporting. So if EB is equal to EC, then EB plus EC is equal to 2 times EC. Like that it would happen. So according to question, they said the magnetic field is upwards. Based on that, this is the answer. So answer key given is wrong. This is a which one, Pathfinder question actually, and that answer key is actually wrong. So just make that correction. If you go by this method, magnetic field is down. You go against the question, what the question is give, then you will get the correct answer. Okay, so but according to question, this is our answer. I'm hoping that you have understood, right? We'll stop it here then. Thank you.